Okay, today we're talking about transversal parallel lines, and transversal and parallel are both big words. To just let us know, parallel lines mean two lines that will always be the same distance apart from each other. They never get any closer, they never get any farther apart, and they will never touch over time. That is what parallel lines means. Now, the word transversal, so we've got two parallel lines there, A and B. The word transversal means a line that crosses at least two other lines. And it can cross it in a lot of different ways. It could be straight up and down. It can be side to side. In this case, our green line, or line C, is transversal, and it's kind of going at a little bit of an angle there because we're going to be focusing on our angles today for our transversal parallel lines. So the first thing I want to do is label my angles, and so I'm going to do that angle 1, 2, 3, and 4. And if I've labeled those angles, I can think back, and just by looking at line A, I can remember some properties of angles. I know that supplementary angles are two angles that when added together are going to equal exactly 180 degrees. And in this case, I have several pairs of supplementary angles. As an example, I have angle 1 and 2 are supplementary. You add those together and they are going to equal 180 degrees. I also could do lines or angles 2 and 3, or angles 3 and 4, or angles 1 and 4. All of those are supplementary angles, angles that add up to equal 180 degrees. I also want to remember the term opposite or vertical angles. Vertical or opposite angles are angles that are opposite of each other, and these ones don't equal 180 degrees. What we know about opposite angles is that they equal the same as each other. So I know that 1 is exactly the same as angle 3. And the same thing is going to be true for angle 2 and angle 4. I know they're going to be exactly the same. Now, I'm going to continue to label some of my other angles here. So I've got 5, 6, 7, and 8. And I could look at some of those similar properties with those angles as well. So let me go back real quick. 5 and 6 are supplementary angles. They add up to 180 degrees. 6 and 7 are supplementary angles. 7 and 8 are supplementary angles. And 5 and 8 are also supplementary angles. And just like we just talked about, our opposite angles are exactly the same as each other. And so I know that 5 is the exact same as angle 7, and 6 is the exact same as angle 8. Now, if we are looking at our two parallel lines, I'm going to look at line A and line B, and I am doing that right now. What I want to notice is some important aspects of our angles. The first thing that we are going to look at today are what are called corresponding angles. My corresponding angles today, I'm going to choose one specific color. Corresponding angles are angles that are the exact same angle if one of the parallel lines were to move. So what we're going to imagine for a moment is that parallel line B is going to move upward. Okay, and it's going to move into the exact same spot as line A. If that happens, exactly one angle, will be in exactly the same place as angle 1 right now. And that angle, or the corresponding angle to angle number 1, is angle number 5. So I'm going to mark that there. Now, the same thing is true for angle 3, which I already know that angle 3 is the same measurement as angle 1. Therefore, I know that it's the same angle measurement as angle 5, because I just said that angle 5, if I move this line up, is going to take the exact same place. Therefore, the same thing should be true if angle 3 is the same as angle 1 and angle 5 is the same as angle 1, then therefore angle 3 and 5 are also the same as each other. Our next piece is I want to figure out which angle is going to take the place of angle 3 if I were to move the line up. And it would be angle 7. So angle 1 and 5 are corresponding angles. Angle 3 and 7 are also corresponding angles. But we also have angle 2, and angle 2 has corresponding angles as well. So I'm going to make angle 2 with a different color. This time I've chosen blue. And I'm going to follow the same process. I want to know which line is in the exact same spot as angle 2 if line B were to move just directly upwards. So that would be angle 6. And I know that angle 4 is the same measurement as angle 2. That means that 4 and 6 are also the same. And the corresponding angle with angle 4 is angle 8. So I could very quickly make a list of corresponding angles, and I'm going to choose to do it on the side that the angles are. Angle 1 and angle 5 are corresponding angles. Angle 4 and angle 8 are also corresponding angles. Over on this side, it's angle 2 and angle 6, and angle 3 and angle 7. Those are my corresponding angles that we have. Now, the next piece that we're going to look at is going to be just interior angles. So I'm going to ignore the angles that are on the outside because interior means inside. So I'm going to do that right now. So what I've done right now is I'm just focused on the interior angles, and I'm going to remind myself that interior means inside. So I'm just focused on these inside angles. Now, it's pretty easy to see right now which angles are going to be the same. When we talk about interior angles, we're going to use what are called alternate interior angles. And the word alternate means opposite. So I'm going to look at angles that are on the inside of my parallel lines that are opposite of each other. And because of the way that we colored these already, you can see that angle 4 and angle 6 are both on different sides of that transversal line. They were both colored in blue. These angles are the same. If we were to go back and remember, angle 2 that was over here was the same as angle 6. That's down below. And because angle 2 and angle 4 are opposite angles, I also know then that angle 2 and 4 are the same, therefore angle 4 and 6 are the same. The exact same thing would be true with angle 3 and angle 5. Those are alternate interior angles. Because angle 1 over here, again if I were to just imagine for a minute, angle 1 right there, and angle 3 are opposite angles, and I know that those are exactly the same. And angle 5 is a corresponding angle to angle 1. Angle 1 and angle 5 are the same. Angle 1 and angle 3 are the same. If that's true, then that means that angle 3 and angle 5 are the same as well. Those are alternate interior angles. Now let's look at alternate exterior angles, which means on the outside. So I'm going to do that by ignoring what's in the middle. So what I've done is I've ignored what is inside of the middle there. Now what's really neat about these alternate exterior angles is you can almost see this right now once we've kind of covered up what's there. If line B were to move right up, you're going to see that angle 1 and angle 7 are going to be opposite angles, just like angle 1 and 3 are. Therefore, angle 1 and 7 are alternate, meaning opposite sides of that transversal line. Exterior, meaning on the outside of those parallel lines, angles. They're alternate exterior angles, and those alternate exterior angles are going to be exactly the same. The same thing is true about angle 2 and angle 8. They are going to create opposite angles with each other. Okay, so here's what we want to do. We want to practice this with a quick example of how we can use all these angle properties to help us out. So let's take a look here. I'm going to create some more parallel lines just like we had before. Here is one line and my second line. Those are parallel lines. No matter what I do, they're never going to get any closer to each other. They're never going to get any farther away apart from each other. I've got a vertical line, and I'm actually going to change the direction because the direction doesn't matter. If it's up, down, if it's going at an angle, it's not going to make a difference. And I'm just going to label my lines again just like I did before. Line A, line B, and my transversal line is line C. Once I've done that, I'm going to label my angles. I've got angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, we're going to leave blank for a second, and angle 8. So there's our angle 8 through 1, and we're going to pretend for a moment like we know the measurement of angle 7 down there. So we're going to say that's definitely an acute angle. It's less than 90 degrees. I'm going to say it looks like about 60 degrees. Now, with just that one measurement, I can figure out every other angle in this entire sheet. I'm going to first do that by reminding myself of my corresponding angles. Angle 1 and angle 5 were corresponding angles. Angle 3 and angle 7, or what is 60 degrees, are corresponding angles. Those are also opposite. Angle 1 and 3 are opposite. Angle 5 and 6 are opposite. So just with that information right there, I can start to figure some things out. I know that angle 5 is equal to 60 degrees, and I know that because it is an opposite angle. Oops, went forward a page. Okay, and didn't have enough room for my E there. I know that angle 1 is also equal to 60 degrees. And I know that because it corresponds, and I'm just going to go core, with angle 5. I also know the measurement of angle 3, and there are two ways that I can know this. I know that it's equal to 60 degrees because it corresponds with angle 7, or with our 60 degree measurement down here. I also know that it is opposite of angle 1. So I've just figured out 4 angles right away really quickly. Well, I can use those properties of supplementary angles to remind myself that angle 6 and angle 7, if I add them together, are going to equal 180 degrees. So I'm going to do a little bit of math real quickly, and I'm going to go 180 subtract 60 gives me the measurement of angle 6. So I'm going to say gives me angle 6, and I know that that's going to be equal to 120 degrees. I'm going to make sure that my answer makes sense. I'm going to estimate angle 6 definitely looks like an obtuse angle. It's over 90 degrees, and I would say that, yeah, it probably looks like it's about 120 degrees. Now, if I know the measurement of angle 6, I also know the measurement of angle 8. So I can say angle 8, oops, I'm going to switch pens there. Angle 8 is equal to 120 degrees. Now, I could do this for a lot of different reasons. I could say that it's because it is opposite of angle 6, which we just did. I could also say that it's because it is supplement with angle 7, which we also just did. Okay, either of those two things would be correct. Well, if I know that that's true, I could do the same thing up here for angle 2. I could go, hey, angle 2 is a corresponding angle with angle 6. So therefore, angle 2 is equal to 120 degrees because it is a corresponding angle with angle 6. I could then remind myself that angle 4 is going to be the exact same angle measurement. Oops, and I just realized I wrote 12 degrees, not 120 degrees. So that's a way that we can use these vertical angles, corresponding angles, alternate interior and exterior angles to help us solve some information that we have in this equation.